Hey teachers, welcome back to part 3 of our video for lecture for section 13-1, where we're talking about linear measure. And I just want to wrap this up with a few examples. So find each of the following, and I have these on different pages, so I promise there's more than one question. So I have an A, a B, a C. The circumference of a circle with radius 2 meters. Now, you do not have to draw a circle to pull this job off, but I want you to realize what you're doing. So there's my best circle. And what do we have here? We have a radius. Remember, it's important if this says radius or if it says diameter. There's two different formulas. So radius is from the center to any point on the circle, and that is 2 meters. So the formula for circumference, which is really the distance around. So what I'm really calculating is if I were to walk around this thing, how far would I walk? That's really all I'm calculating. So circumference, we have two formulas. One of them is 2 pi r, and the other one is pi d, okay? Now, they calculate the same thing. Again, it's the given information, and we have a radius value. So I'm going to use this one. C is equal to 2 pi. My radius is 2 meters. I made this way harder than it really needs to be, right? It's easy. 2 times 2 is going to be 4 pi meters. Is that okay for an answer? Oh, you bet it is. That's exact. If I type that in my calculator, which you should be able to find a pi button in a scientific calculator. Now, if you're using a super basic calculator, then you don't have a pi button. And if you needed this in decimal form, I would just use pi as the approximation, make it squiggly, approximation 3.14, and then you can multiply that. But listen, if you want an exact answer, and a lot of the homework does, 4 pi meters, you actually use the pi symbol. All right, that's it. That's all there is to that one. So, and yeah, see, there's their typed up answer, exactly what we put, 4 pi meters. Again, if you needed a decimal version of that, you really wanted to know how big it is, because 4 times 3.14 is about 12 something, right? 12 and some decimals. Okay, so that tells you walking distance. It would be a little over 12 meters, maybe closer to 12 and a half meters, right? Okay. Here's example B. Why don't you pause it and do this one on your own? All right, how'd it go? So the radius of a circle with circumference 15 pi meters. Okay, this time, y'all, they want to know the radius, and we know the circumference. Formulas are the same, right? Circumference is equal to 2 times pi times r. So I'm going to plug in 15 pi in place of my circumference, because that's what they told me it was. And over here, I have 2 pi r. Now, what am I trying to find? I'm trying to calculate r. So you know what we're going to do? We're going to use our properties of equality that says if I need to isolate this value, and right now I'm multiplying it times 2 pi, to undo multiplication, I'm going to divide both sides by 2 pi. Another way you could handle that is what you're really doing is multiplying both sides by 1 over 2 pi. Because the property of equality says you can multiply both sides by the same value. It doesn't mention dividing, but y'all, dividing really is just about multiplying by the reciprocal. Okay. Now I'm not doing it both times. I just wanted to say this is an or situation if you're being very particular about your rules. Now, what do we have? 15 pi divided by 2 pi. Are you wondering if those pi's cancel? They do. Okay, that's gone. So your answer is 15 halves is equal to r. Do you need to change that to 7.5? Sure you can. Why not? So 7.5 what? I left my units out, didn't I? The circumference was 15 pi meters, okay? There are no units over here in the formula. Well, the radius is in units, and so our answer, meters, is still sitting there. So 7.5 meters. Be careful about how you're supposed to enter your answer if this happened to be a homework problem. See, look, they wrote that one as a decimal. Sometimes it asks for a decimal, sometimes it asks for a fraction, sometimes it'll accept an improper, sometimes it won't. So just be very careful about reading the directions. I think the best answer for that would be the 15 halves meters. But that's just me, you know. But if I wanted it a certain way, I'd have to be specific about it. Okay, here's a C. That's worth trying on your own as well, although this is an arc length problem. You remember the formula for arc length? So the formula for arc length, they called it L. I've seen books call it S, and in trigonometry class we call it S. But the arc length L is pi r theta divided by 180 degrees, okay? Theta is also in degrees. Now, it says the length of a 25-degree arc, so that is your theta, with a diameter of 10 centimeters. We got to think about this a little bit, don't we? So I don't have R in my problem. Well, this is D, right? What do? How do D and R relate? Well, R is halfway across the circle. D is all the way across the circle. So doesn't that mean R is 5 centimeters? Sure it does, right? So we have pi times 5 centimeters times my theta, which is 25 degrees, divided by 180 degrees. This is just a plug straight in situation. Now, 5 times 25 is 125. Okay, so now I'm going to move that in front. 125 degrees divided by 180 degrees, and I still have pi as part of my answer. Now, if I wanted that in fraction form, I would reduce both of these. I do see that they both divide by 5. That might be the biggest thing they both divide by. And when I say they both divide by, that's the greatest common divisor, right? So let's bring in some of our old class stuff in. The greatest common divisor of 125 and 180 is 5. So 125 divided by 5 gave me 25, and 180 divided by 5 gave me 36. 25 and 36, the greatest common divisor is 1, which means my fraction is in lowest terms, completely simplified, lowest form, and the pi is still part of the answer. I like this answer. Again, I don't know if they want a decimal version or not, but let's take a look. Okay, so here's what they put. They put 25 pi over 36. Sure, and then they converted it. Notice the wavy approximation, because when you type in pi, it is an approximation of 2 1800 centimeters. Okay, now I do want you to notice something, and I'm positive you're comfortable with this, but this is their answer, and I had this, 25 over 36 pi. Is that the same thing? Is it okay to put pi outside, or do I have to move it up here in the numerator? Are they the same thing? I'm hoping you're saying, yes, ma'am, they are the same thing for sure. How do you know? Because you could put pi over 1 and multiply those together, and that would give you 25 pi over 36 times 1, which is 36. Either or is fine. It really doesn't matter which way you write it. Now I have a part D for you, way down here at the bottom, with not enough room to get it done, but we're going to do it anyway. So it says the radius of an arc whose central angle is 87 degrees and whose arc length is 154 centimeters. So remember, what we're looking for is radius. We're trying to find radius. What do we know? We have the angle of 87 degrees. Notice they called it a central angle. That's really what you have to calculate arc length. If you don't have a central angle, you can't use that formula. If you had some other, what do I mean by central angle? So a central angle is an angle that comes from the center of the circle. If I had some kind of angle like this, we would have different work to do. It would not be the same formula, okay? All right, so central angle, I've been just assuming, right? Even this one, the length of a 25-degree arc, it didn't say a central angle, but that is a central angle. Okay, all right, so the radius of an arc whose central angle is 87 degrees and whose arc length is 154 centimeters. So remind me, what's the formula? Remember, the arc length is L. Uh-oh, my pen working. So L is equal to pi r theta over 180 degrees. All right, so I think I'm going to go to the top of the screen. I'm going to erase our central angle, depiction and just work at the top of the screen so I don't have to add another page. So let's plug in what we know. We're looking for radius. Okay, so my R is going to stay in my formula. My central angle, 87 degrees, that's my theta. Okay, and then 154 centimeters, that's my L. All right, so let's just plug in. So I have 154 centimeters is equal to pi R times 87 degrees over 180 degrees. Now, it turns out our degrees units cancel out. So that degree symbol cancels with that because one's in the numerator, one's in the denominator, right? Okay. Now, I'm trying to solve for R. I'm trying to get the R by itself. There's a few things we need to do here. Okay. Now, on top here, pi times 87, I want to divide by that because it's multiplied now. And I'm dividing by 180, so I want to multiply that. So watch what I'm going to do. I'm going to multiply the left-hand side, the whole thing, by 180 over pi times 87. And I'm going to multiply the right side by that also, that same exact fraction. Now, the 154 centimeters is still there. Now, just imagine with me, if I multiply this same green fraction over here, okay, upside down, it's the reciprocal. The 180 is going to cancel with the 180 in the numerator. The pi is going to cancel with the pi in the denominator. And the 87 is going to cancel with the 87 in the denominator. And that leaves me with just R. Okay, make sure you stop it, write that down, and you see that. I'd really just multiply by the reciprocal on both sides. So 180 over pi times 87. So now I'm just going to multiply this in my calculator. This, what do you mean? All of this in my calculator. 180 times 154 divided by 87. And I'm just going to leave the pi in the denominator. Okay. So again, 180. I'm doing it now. Times 154 divided by 87. And that gives me a crazy decimal. So that's going to be 318.62, writing it over here to the left, 318.62, and that keeps going even, over pi. And that equals to R. Now what I could do is also divide both sides by pi, or divide it by pi, not both sides. We've already handled that. So if I divide by pi, I get 101.42, and that keeps going as well, is my R value. Now again, anytime you're asked this question, they're going to be very specific about the answer. It'll either say in terms of pi, which means you leave your pi in your answer and leave it alone, or it's going to say a decimal rounded to a certain place. Let's see what they decided to do. Again, we have 318.62 over pi, which simplifies to 101.42. There it is, way at the bottom. There's the 101.4, right? Centimeters, okay? So we did it. They didn't even convert or anything. They just went straight to the final answer. Again, you will always be told where to round. Those examples, though, were just not set up with a place to round. So I'm done. I'm done. I tried to stretch it out, didn't I? But at least we didn't get to 30 minutes again. So this is a thorough lecture of section 13-1. So come back for 13-2 where we talk about area and units of area. I hope you have a wonderful day.